Exponent rules for multiplying. This is an exponent right there. It's the number that is on top of our base. And what it means is to multiply that base that many times. So 3 times 3 times 3 times 3. X cubed would be x times x times x. And all of our rules are expanded from this. It's more of a, it's just because it works situation. So if you have x to the 5, that'd be x, 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 x. So what I want you to do is expand all of these for me. Okay? And then unpause it, and we'll figure out what we have going on with multiplication. Alright, so if they're expanded, x to the 5 would be x multiplied by itself 5 times. Same with x3 and x7. Well, if we count them up, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we answer this question for A, B, and C, how many x's are you multiplying in each problem? The first one's 5. Second one's 10. How many total? Well, 3 plus 4 is 7. And how many x's here? Total of 5. Not about the y's, just the x's for right now. So if you look at that, what operation is happening between the exponents? Is it addition, multiplication, division, subtraction? Exactly. It's addition. And that's it. If you have 3 and 7, you would add them together. That's it. Alright. So what if you have this? What would x to the 5 times x to the 15 be? You guessed it, it's x to the 20. You just add them. Okay. So what about this now? So what if you have a power to an exponent? What's the operation here? Well, if you take 2 squared and put cubed, that's 2 squared, 2 squared, 2 squared. Well, what's 2 plus 2 plus 2? Exactly, it's 2 to the 6. And then 2, 2, and 2. That's x to the 6. And this would be x to the 4 plus 4 plus 4. It's a 12. So I want you to do the same for all of these. I want you to expand them out and put x squared, x squared, x squared, x squared for each of them. And then the same thing here. Okay, hit pause. Okay, so that's the expanded form for each of them. So remember, the rule for multiplication is you add. So 2 plus 2 plus 2 plus 2 is 8. And remember why? That's 2 of them. That's 2 of them, 2 of them, and 2 of them being multiplied for a total of 8. So if we do this one, let's look at the x's. It's 2 plus 2 plus 2 plus 2. That's a total of 8. And then the y's would be 3 plus 3 plus 3 plus 3, which is 12. And then let's look over here. It's 2 times 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And then the x's is 3. So that's 12. Okay. So if you look at our starting problem, we had x squared to the power of 4. And we got x8. We had x squared to the power of 4. We got x8. And then x cubed to the power of 4. We got x12. With the other stuff added in. So how many x's are you multiplying in each? So we have 8, 8, and 12. So what operation will give you that? So is 2 times what will give you, 2 times 4 is what? 8. It's multiplication, I just told you it. Multiplication. That's it. So if you want, if you're multiplying, you add the exponents. And if you have a power, you multiply the exponents. So for this one, this is just a straight multiplication. We use our rule, which means we multiply the numbers. So that's negative 6. We put the exponent, the letters together. And then what is 2 plus 3? It's 5. Bring down the negative 6, and that's your answer. You can also just expand it out. If you really don't know what it is, just expand it. Remember, that exponent only belongs to the x, not the 3. It's negative 3, and then you have x times x times x. So that would be negative 6, and then 1, 2, 3, 4, 5 of them. x5. That took all of 2 seconds. It's best to not guess. If you really don't know, expand them out. It'll tell you what the answer is. Okay, so this one. This is x squared, x squared, x squared, and then 2 plus 2 plus 2 is 6. So even if you don't know the rules, expanding them out will tell you what it is. But if you do want to use the rules, it's multiplication. So we multiply the two numbers. And when you multiply the same bases, you add the exponents. If it's an exponent with an exponent, it's a power. Then you multiply them together, and that gives you 6. It's very clean. So if you have x5, x2, this will give you x10. All right? Here's a bunch of problems to try all the way down. So hit pause, give them a shot, and then I will put all the answers up. So hit pause now. Okay? And here are all the answers. Okay, so let me answer probably some of the questions you're thinking about. So up here, x3, why is it not x3? There is a 1 here, and you have to count them. Remember, if you expand it, it tells you there is 4 of them, x to the 4th. And then down here, if you were to expand it, it's negative 2t, negative 4t, and 5t. Like I said, expand it if you still don't quite get it. Eventually, it's going to just click. You'll start seeing it the more you expand it. So that would be 8, which is times 5, which is 40, and then we had 3 plus 2 is 5, plus another 5, which is 10. That's it. And then same thing over here. If you had 13 sets of these, you'd have 65 of them. The 2, you still have to use the cube, so it's 2 cubed, and then x5 cubed. So you have to do them both. Or if you were to just expand it, 2x5, 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 you would see that we get 2 times 2 times 2, which is 8, and then 5 plus 5 plus 5 is 15. And then there are the rest. Take a look at them. Now all together at the very end, you have multiplication and you have subtraction. In order of operations, multiplication will come before subtraction. So you have to do these and these first, and then with subtraction, all we have is that one rule. Are they like terms? We have a9, a9. So yes, they are. We have 14 a9ths, take away 30 a9ths, for a total of negative 16 a9ths. And then for the other one, we have 1 of these and 1 of these, for a total of 0, because 1, a5, b6, take away 1, a5, b6 gives you absolutely nothing. Thank you.